In the last video, we talked about thrift and protocol buffers. Apache Avro is another binary format that is interestingly different from protocol buffers and thrift. It was started in 2009 as a sub-project of Hadoop, and as a result of thrift not being a good fit for Hadoop's use cases. Avro also uses a schema to identify the structure of data which is being encoded. It has two schema languages. One is Avro IDL interface definition language, which is intended for human editing, and one based on JSON that is more easily human readable. So this is how our example schema, which we saw in the previous video, it looks like when it's written in the Avro IDL. So as you can see, there are no tag numbers included in this schema like we had with thrift. Also, the favorite number field is an optional field here. That's why it's a union of null and long type. Now if we encode our example record using this schema, the Avro binary encoding is just 32 bytes long, and this is the most compact of all the encodings that we have seen. So let's see how the breakdown of each field looks like. In this byte sequence, you can see that there is nothing to identify the fields or the data types. The encoding simply consists of the values which are concatenated together. So here username, it's just a length prefix followed by the UTF-8 bytes. But there is nothing in the encoded data that tells you that it is a string. Also the integer 1337, it's encoded using a variable length encoding, which is the same encoding that we saw in case of thrift's compact protocol. Also the number, the length of this username field, which is also encoded as a string. This also uses the same encoding pattern, the zigzag encoding that we saw in case of thrift's protocol. Now for arrays also, it's doing the same thing. It's just appending the length of the array and the next the length of the string, and then the UTF contents of that string. So this is a simple encoding scheme. So to pass this binary data, you go through the fields in the order that they appear in the schema, and then you use the schema to tell you the data type of each field. So this means that the binary data can only be decoded correctly if the code which is reading the data is using the exact same schema as the code that wrote the data. And any mismatch in the schema between the reader and the writer, it would mean it's an incorrectly decoded data. So with Avro, when an application it wants to encode some data to write to a file or a DB, it encodes the data using whatever version of the schema it knows about. For example, the schema may be compiled into the application itself. So this is known as the writer schema. Now when an application wants to decode some data, like read it from a file or database, receive it from the network, it is expecting the data to be in some schema, and that schema is known as the reader schema. So the key idea with Avro is that the writer schema and the reader schema, they don't have to be the same, they only need to be compatible. So when the data is decoded or read, Avro library it resolves the differences by looking at both the writer schema and the reader schema side by side, and then translating the data from the writer schema into the reader's one. For example, it's not a problem if the writer schema and the reader schema they have their fields in a different order, because the schema resolution it matches of the fields by field name. So if the code reading the data encounters a field that appears in the writer schema, which is here in the left, but it doesn't appear in the reader schema, for example this photo URL, then it is ignored. Also, if the code reading the data expects some field, for example here a user ID field, but the writer schema does not contain a field of that name, it is filled in with a default value which is already declared in the reader schema. So with Avro, forward compatibility means that you can have a new version of the schema as a writer and an old version of the schema as a reader. Conversely, the backward compatibility, it means that you can have a new version of the schema as reader and an old version as the writer. And then the same compatibility rules apply here also, that you can only add or remove default values to maintain forward and backward compatibility. Now, how does the reader know the writer's schema with which a particular piece of data was encoded? We can't just include this entire schema with every record because the schema would likely be much bigger than the encoded data, and this will discard all the space savings that we get from the binary encoding. So the answer depends on the context in which Avro is being used. Let's see a few of those examples. A common use case for Avro is, especially in the context of Hadoop, is for storing a large file containing millions of records. So all encode, and it's all encoded with the same schema. Now in this case, the writer of that file, it can just include the writer's schema once at the beginning of the file. So Avro also specifies a file format, which is object container files, to do this. Now second example, in case of a database, different records in the database may be written at different points in time and using different writer schemas. So you cannot assume that all the records will have the same schema. So the simplest solution is to include a version number at the beginning of every encoded record and to keep a list of schema versions in your database. Now a reader, it can fetch a record, it can extract the version number and then fetch the writer schema for that version number from the DB. And using that writer schema, it can decode the rest of the record. So Espresso DB, which is developed by LinkedIn, it works in this way. Again, when two processes are communicating over a bidirectional network connection, they can negotiate the schema version on connection setup and then use that schema for the lifetime of that connection. The Avro RPC protocol, it works in this way. So this is the end of chapter 4. I wanted to keep these videos concise, so I have skipped a few parts in the end from chapter 4 which I didn't find very relevant.